Johannes and Florian are going to test the protection scheme of a 110 kV bus bar. The bus bar has 4 active bays. Therefore, they use 4 CMC 353 test sets. Florian uses his laptop to control the entire test with RelaySimTest. He connects his laptop to all of the CMC test sets with a PTP transparent switch. For synchronized injection, Florian adds a CM GPS 588 time reference to the test setup. He connects the CMCs to the bay units and the central unit. He prepared this test the day before. The test models the bus bar topology within RelaySimTest. The test comprises 6 test steps. Steps 1 and 2 will test the bus bar stability, and steps 3 to 6 will simulate various fault situations. RelaySimTest recognizes the devices while Johannes switches them on one by one. Johannes is setting the isolator positions for the following test steps. Florian outputs a current to make sure that the test wiring is correct. RelaySimTest is aware of all the different CT ratios in the individual bays. As expected, the displays show the correct values. This confirms that the wiring has been done properly. Now they can start the test. First, the engineers check to see if the protection is stable during normal operation. Florian outputs various load flow situations. No trip signal appears. The protection has passed this test. Now Florian simulates a fault. Although the fault has taken place in one of the bays, it remained outside of the protected area of the bus bar protection. None of the bays have tripped. The protection remains stable. Next, Florian sends a fault through bus bar 2. Since the dynamic simulation does not react to the relay's selective trip commands in real time, the fault persists. Therefore, the protection trips the complete bus bar with a time delay. This shows that the breaker failure protection works. Since RelaySimTest has remembered the relay's initial selective trips, it calculates the signals accordingly to repeat the previous test step with the correct simulation of the breaker operations. Now the protection clears the fault selectively. When Florian triggers a fault between the CT and the circuit breaker in the coupling field, RelaySimTest applies its iterative closed loop feature once again. As expected, the protection finally trips the complete bus bar, since it is unable to clear a fault within the dead zone selectively. By closing the second isolator of one of the bays, Johannes links the 2 bus bars to one another. Florian checks to see if the protection can also handle this case correctly. Once again, he uses RelaySimTest's iterative closed loop testing feature. He repeats this step with the circuit breaker connected in a closed position. The protection has also passed this final test. The test results show that the bus bar is well protected. The bus bar can be activated by station control. For the first time, an iterative closed-loop approach could be used to test a bus bar protection scheme logic. Correct installation and proper function of the protection system was ensured through synchronized injection at all bays. All of the injected signals were calculated by RelaySimTest. The entire logic could be tested more quickly and comprehensively than ever before.